Next, we're going to turn our attention to what turn out to be reflections if you multiply the function by a negative or replace x with negative x. And for this one, I like to use square root of x. That's one of our nice toolbox functions. And it's not symmetric across either axis, so the reflections actually give us different graphs. So let's start with making a table. Here, I'm not going to do negative 2 to 2 because the square root of negative numbers are imaginary. So I'm going to use perfect squares. I'm going to use 0, 1, 4, and 9. So the square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and then 3. We get 0, 1, 2, 3 for those y values. So this graph actually starts at 0, 0, goes through 1, 1, 4, 2, and 9, 3, and we get this graph. One of my algebra books calls this a one-wing graph. You only kind of get this one side of it going off here, and the domains from 0 to infinity. Now, the vertical change, which is what a negative square root of x does, changes the y values. It's pretty easy to see directly with the table. I can use the same x's and I'll get 0, negative 1, negative 2, negative 3. By doing negative 1 times the square root of x, I'm literally changing the sign of the y values, and we get a reflection across the x-axis. Together, the square root of x and the negative square root of x make a sideways parabola. Together, they would be the full inverse of x squared. So if you multiply f of x by a negative, you get a reflection across the x-axis. If you replace x with negative x, you would have to change your x values to make a table. So really what you're doing here in function notation, we're replacing x with negative x. I can do that in the table, and then I would have the same y values. Square root of negative 0 is 0. The two negatives would cancel. The square root of negative negative 1 will be the square root of 1, which is 1, and then you get 2 and 3. So same y values, opposite x values, we get the reflection across the y-axis. So negatives create reflections. If you multiply the entire function by negative 1, or put a negative out in front here, which is what's happening if you multiply by negative 1, you get a reflection across the x-axis. And if you, sorry, I didn't like my little extra mark there. If you replace x with negative x inside the function, you get the reflection across the y-axis. So if you know what f of x looks like, negative f of x will look the same, reflected mirror image across the x-axis, and f of negative x will be the reflection across the y-axis. Now let's look at some stretches and shrinks. What if we multiply y by a value other than just negative 1? What happens? Well, it either stretches or shrinks the graph vertically. So we've seen absolute value of x earlier. You get a V-shaped graph. If I drew this with a straight edge, I've done the best I can on my iPad here, but if you did this with a straight edge, you'd have this perfectly straight V shape. And then if we were to do 2 times absolute value of x, that changes y values, which is always easier to show in the table than changing x values because you can keep the same x's. It would just double the y values. So if I take the y values for absolute value of x and multiply them by 2, I would have the y values for 2 times the absolute value of x. It looks like the graph gets skinnier, and it does in a sense, but what's happening are these y values are doubling. I have 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4. My new y values are twice as tall as the original y values. And same thing happens on the negative side. We get our V shape that's twice as tall. Now if I pick a number that's between 0 and 1, such as 1/2, we're going to make the graph shorter. So we would have half of 2, half of 1, half of 0, half of 1, half of 2. So same x values as the original graph, cut the y values in half. We get a vertical shrink by a half is what we would call this. So it's shorter graph vertically. Looks wider as well, but it's vertically shorter. So those are stretches and shrinks, vertical stretches and shrinks. So if you take f of x and you know what that graph looks like and you multiply by a, it depends on the size of a. Now if a is negative, you get a reflection across the x-axis. So if you just focus on positive values of a for this, or the absolute value of a itself, when that's positive, or when that's greater than 1, you get stretches. Think of it as you're doubling, you're tripling, you're making it taller. It's going to be a vertical stretch. But if you pick a number between 0 and 1, like 1/2, 1/3, 1/4, you multiply by that, you're making the heights shorter, so we call it a vertical shrink, or some books will use the term vertical compression to sound a little fancier.